Chapter 1.11.8 Traces for Kubernetes System Components. Summary. Kubernetes version 1.27, beta, includes tracing for system components, recording latency and relationships of operations within the cluster. Components emit traces using OpenTelemetry and gRPC, which can be managed via collectors, recording API and kubelet operations. Tracing aids debugging, showing parent-child links between actions, but could affect performance. Adjust sampling rates to balance efficiency. Traces for Kubernetes system components. In Kubernetes version 1.27, system components can track and record how long operations take and their interactions within the cluster. This is done using the OpenTelemetry protocol, with trace data being sent through the gRPC exporter to tracing backends via an OpenTelemetry collector. Trace collection. This code snippet specifies the configuration for trace data collection using the OpenTelemetry protocol, OTLP, with gRPC as the protocol for the Kubernetes system components. It includes settings for the OTLP receiver and exporter, as well as logging details such as log level for debugging purposes. Finally, it defines the pipelines for trace data, specifying the receivers and exporters to be used in the trace collection process. Kubernetes components can export traces with built-in gRPC exporters using the OTLP protocol, either utilizing an OpenTelemetry collector or directly specifying a backend address. To collect traces, a receiver configuration is needed if the collector is used as a sidecar. Logging spans to standard output. This configuration is specified in the Kubernetes tracing configuration file. Setting trace backends without a collector is possible by defining the endpoint field. Authentication and trace resource attributes can be managed using specific environment variables. Component traces. This code snippet defines a tracing configuration resource with the API version of appserver.config.k8s.io/v1beta1. The tracing configuration specifies a sampling rate of 100 per million for tracing. The default endpoint value is commented out, but it can be specified as localhost 4317 for exporting traces. The code snippet configures the Kubernetes kubelet to enable tracing with the feature gate kubelet tracing set to true and defines tracing configurations such as endpoint and sampling rate per million. This configuration allows the kubelet to collect and export traces using the specified endpoint and sampling rate. The kube appserver traces incoming and outgoing HTTP requests, generating spans. It propagates a W3C trace context with outgoing requests but ignores it for incoming ones, given its public endpoint nature. To activate tracing, configure the kube appserver with the tracing config file equals less than path to config greater than. A typical configuration logs spans for 1 in every 10,000 requests, using the default OpenTelemetry endpoint. More details on structuring tracing configurations can be found in the API server config API v1 beta 1. In Kubernetes version 1.27, the kubelet's CRI interface and authenticated HTTP servers generate trace spans. These endpoints and sampling rates can be adjusted. Tracing configuration ensures spans without apparent respect the configured rate. If no endpoint is set, data routes to localhost 4317 by default. To enable tracing in the kubelet, employ a specialized configuration that logs, for instance, 1 in 10,000 requests. When adjusting the sampling rate per million to 1 million, all spans are exported. Kubernetes version 1.31 logs additional routine spans and propagates trace contexts with gRPC methods. The kubelet can link spans to container runtimes like CRI-O, aiding debugging. Exporting spans slightly impacts networking and CPU performance. If impacted, adjust sampling or disable tracing to mitigate issues. Stability. Active development means tracing tools might evolve. This affects names, attributes, and endpoints. Tracing feature isn't stable yet, no backward compatibility guarantees.